purpose of this video is going to be show you how to do the basic setup for an FPV Freestyle quadcopter. I'm going to be using a 7-inch quad as my demo quad, but the basic setup will be the same for any quadcopter, whether it's a little 2-inch or a large 7-inch like we're going to be working on in these videos. The basic process is the same for all of them. What you're going to need to do this is, of course, a quadcopter that you're going to be setting up with the Betaflight firmware. You are going to need at some point a LiPo battery so you can turn on the quad and make sure that the ESCs and motors are working properly. And you will need the radio controller that you're going to be using when you fly this particular quadcopter. The other thing you will need is to have Betaflight installed on your computer. If you don't have that done right now, I've got another video that shows you exactly how to do it, and that's linked in the video description below. Once you have Betaflight installed, what you will do is start Betaflight on your computer, plug in your USB to the computer and the quadcopter. From this page, what you will see is a list right here of available ports for you to connect to. Now, if you're on a PC, they're going to be listed as COM ports, and they can have a number anywhere from basically 1, I think, up to maybe 16, something like that. So just choose the one that shows up for you on your computer. Typically, it will be labeled as a Betaflight or STM32, something like that, that will indicate it's from the quadcopter. On a Mac, it's going to be coming up as a USB device, and it will have a very long name. But that will be the one that you will choose. Once you've chosen the correct COM port, all you need to do is click connect. After we have connected here, we're going to come down and toggle this little switch right here that allows us to enable expert mode. And what that will do, if I turn it off right now, and we look on the left side of the screen, you'll see that there is a list of available tabs and pages that we can take a look at. And when we enable the expert mode, we get a few more available to us. One of the important ones is the failsafe. And so we want to turn that on so we can see all of the options that are available to us. On this page, which is the very first page you come to when you get into Betaflight, is the setup page. And it gives us a little bit of information on the right side of the screen over here about the components that are in the flight controller, its basic setup right now, some errors or some indicators of why you might not be able to arm your quadcopter at this moment, and just a few other pieces of information. Right now, we're not worried about those. They'll give us details later on. What we do need to do on this page is come over here, and we need to calibrate our accelerometer. It's a very simple process. Just follow the steps, and then when you are ready, you will click the accelerometer button. So we will do that right now. And to do that, we're going to need to make sure that the quad is in a level place and that it's stable in that place. In my case, if we take a look at this one, you can see that it's got a bit of a wobble in it. And that's simply because of the screws here on the bottom. They're all slightly different sizes, and so they stick out at different distances, and they just make it a little bit unstable when it's sitting on the table like that. If that's the case for you as well, you're going to need to do something in order to level it out and make sure that it's stable. The simplest way is just to get yourself something that you can put underneath the quad that's big enough so that when you put it on top, it will only touch on the arms. And then having done that, you'll see that the wobble is gone. And so now it's in a nice stable position, and we can simply click on the calibrate accelerometer button, and we'll get a nicely calibrated accelerometer. So once you have that set up for yourself, click the calibrate accelerometer, and then we will go on to the next step. And on this page, that is all we need to do. So what we can do now is move down to the second part here, ports. And what we will do on this page is we will let Betaflight know all of the components that are attached to the quadcopter and how they are attached, or maybe where they are attached. On my build here, and this will be could be very different for you, but on my particular build, on my quadcopter, UART number 1 is used for, in this case, smart audio or IRC tramp. I fly with analog video, and so I'm using IRC tramp. So we'll put that one on there. For me, I know on my particular build, UART 2 is where I have my Express LRS receiver connected. And so I need to select that one for serial receiver. UART 3 for me is unused, so I can just leave everything across there blank. UART 4 is set up as an MSP connection, which it shouldn't be, so I'll turn that off. UART 5 has ESC sensor input on it. However, I am not using that, so I can turn it off to disabled. And on my particular build, UART 6 is being used for a GPS unit. And so I will select it there. And I'm just going to leave the baud rate at 57.6, and it's just fine. So once you have set up the elements that you need to set up for your particular quad, then you would come down to the bottom right corner and make sure you click where it says Save and Reboot. All right, so we've done those first two, the setup and the ports. That's very quick, very easy. We will come down now to the Configuration tab. On the Configuration tab, we have a number of things that we need to take care of in order for the quadcopter to fly as we need it to and as we want it to. The first thing we need to do is come here to the top left and set up our PID loop frequencies. If you are using an F7 based flight controller, you can set both of these to 8K and 8K. If you are using an F405 processor, which is what I am using in this particular build, you should set it down to 4 kilohertz for your PID loop frequency. And this is especially important if you're going to be including a GPS on a build with an F405 chip. The GPS unit adds just enough extra processing to the flight controller chip that you need to drop the PID loop a little bit, just to make sure that everything runs very smoothly and stably. And that is perfectly fine with an F405 chip. Then you should have your accelerometer turned on if that's how you like to fly, and the barometer. I'm building my quad to have GPS return to home in it. Having a barometer activated, because it has one on this flight controller, will help with that. If your flight controller doesn't have a barometer, just leave it turned off. For the personalization, you can put in the name of your particular quad, and if you want to put in your pilot name, you can do that as well. This is information that will just show up on your on-screen display if you choose to show it there. FPV camera angle, we don't need to worry about that at all. And then the arming angle, I like to put mine at 180 degrees, which means regardless of which way the quadcopter is, I can always arm it. If you put it, for example, at, let's just say here, 35 degrees, what that means is if your quadcopter goes past 35 degrees, it won't arm. And that's not very good if you hit a tree or something and you're stuck up in a tree, or you've landed upside down and you want to try to do a flip over, then it won't arm for you. And so if you're flying freestyle FPV, it's a very good idea to put this at 180 degrees, and then it will arm regardless of where it is in its 3D position. Coming down to these other features, always enable air mode. It's a very helpful feature for stability with your quads. I'm using a GPS on this build because it's a large 7-inch build, and so I'm activating it. If you're not, turn it off. In-flight accelerometer, I'm not going to do that, and I'm going to have an OSD, so I'd like to have that activated. Soft serial, I don't need any extra serial ports. Up on the top right, we see a place where we can do sensor and board alignment. Now, just to help you understand what that is if we take a look at a flight controller, we can see that, oops, right over in this corner, it has an arrow. And that arrow indicates the default direction of flight that the gyroscope and accelerometer expect from the factory. So basically when they put that gyro and accelerometer in there, they basically said, this way is forward. And in order for Betaflight to use the data properly, it needs to know which way is forward. So if for some reason, instead of putting this in straight forward like that, for some reason you needed to mount it 90 degrees at an angle, which in this case is a 90-degree yaw, we would need to come over here and indicate that we had done that. If you had switched it and put it this way, for some reason, that's the only way you could get it to fit in your quadcopter. Well, that would be a 90-degree pitch. Okay, and so these are things that we need to change only if you didn't put your flight controller in with the arrow pointing straight forward. Now, mine is set up normal way with the arrow pointing straight forward, so I don't need to make any changes here. It's pretty unusual that you should need to do this, but if you ever do, that's where you would do it. Accelerometer roll and stuff we don't need to worry about. That's only if you are flying in angle mode that it would really matter. The D-shot beacon, that is a beep that can be made by the motors in the case of a lost model, or if you set up a switch on your transmitter to activate the beeper. This is a feature that's only available with D-shot, and realistically, it works quite well if you have bigger motors, but it's hard on the motors, especially if you're doing it repeatedly or for a long period. It can actually cause the motors to overheat and be damaged. The other thing is, if you're using really small motors, they don't make enough sound to be able to hear them. So in my case, what I prefer to do is put in a lost model beeper, which is a separate beeper that is separate power supply, separate everything that you can use and activate with a switch. However, if you want to use the D-shot beacon, this is where you would set it up. I don't use these. I use an external beeper, so I'm going to leave those off. We can also set up the reasons and the situations where we would want the beeper to be active. And so we can see on here that there are a great many of them. There are some that you might want and some that you just don't want because they just make noise all the time. So I don't care when my gyro is calibrated, it's already done. If I lose transmission, I want it to beep. If I've lost transmission and it's coming down and landing, I want it to beep. I'd like to know that. I don't care about a beep when I'm arming or disarming. I'm doing that so I know it's happening. This arming and GPS fix, because my build is going to have a GPS built into it, I would like it to go beep, beep, beep when it has a GPS lock. So then I know, and I have a signal that I know that it's done. If my battery is low or critical, I want to get a warning about that and get a beep from it. The RX set means I can use a switch on my transmitter to make it beep. All of these other ones here, I don't care about. They're just extra noise that doesn't help me with any knowledge, so I don't care about them. It doesn't give me anything useful. A USB would mean it beeps when you plug it in. And I like it when I have my crash flip enabled so that I know that I'm flipping over and I can hear the beep that it's doing it. And for me, those are the only reasons I choose to have the beeper beep. You can choose whichever other ones you might, and then all you'll need to do is save and reboot. So we'll do that now. And right back into it. And we can see we've done those first 3 tabs now. And now we're going to get here into the power and battery. So we will do that. And there's very little we need to do here. The first part up here basically tells us how voltage and current is going to be figured out on the flight controller. And in this case, it's using an onboard ADC or analog to digital converter. And we can just leave that as is. These cell voltage here, they are used by Betaflight to try to figure out how many cells your battery has when you plug it in. And so these values give it kind of a high range for a maximum charge and a low range for the minimum charge. So it knows how to distinguish battery cells from each other. So just leave those alone. You don't need to change them at all. The only thing that you might want to do here is if you know that you always fly with exactly the same size of battery on this quad, for example, 5-inch quad, I always fly 1500 milliamp hours. I could put that in here, and Betaflight would use that information to help calculate basically how much percentage of your battery is being used and how much is left. If you don't know that, or if you change your battery sizes frequently, just leave this empty and it will be absolutely fine. Moving down, These are the one place where you need to actually potentially put in some extra information, and you might need to go to your flight controller's website or manual to get the information. So what you're going to need to do here is put in a voltage meter scale and an amperage meter scale. We're going to not do fail-safe yet. We haven't set up enough things in order for us to do this the way we would like to. So we're just going to skip it for now. Actually, we'll come into it. If you are not using a GPS and you are flying a freestyle quadcopter, the best option that you can have for your fail-safe is drop. So basically, if fail-safe happens, it will just drop straight out of the sky and land or crash. It'll crash right at that spot. And for freestyling, because we're typically not long range and we're close to everything, that is the safest way just to get it to drop. Okay, especially if you're flying bandos and things, a GPS rescue won't work. It'll never figure its way out of a bando or anything like that, in trees or whatever. If you are flying in open areas and you have a GPS rescue idea that that's what you're going to do, we would set up a GPS rescue potential or a land as an option. But right now, we don't have everything else set up in order to choose these. And so for now, we'll just put it on drop. And if you are not using a GPS, that's all you need to do. So having done that, we'll come down here and click save and reboot. Now what we're going to do is we're going to come down to this button here called presets. The presets are a really neat feature that Betaflight has added just a few versions ago that really make it easier for us to do the initial setup on our quads. And it's a really nice feature to have. We're going to come over here to the categories. And what we're going to do is choose some of these very specific ones and choose a preset and apply it to the quadcopter to get a very good basic setup with almost no work. If you haven't done this before, it's a really, really good idea when you're starting off with a new quadcopter to save a backup before you start all of this. Now, in a previous video, I showed how we go about doing that. And what we're going to do is we will start here at the very bottom. So we'll start with the RC link. Now, this is really important because it allows the Betaflight to understand the type of link that's coming and the rate that the data is being sent at, and all of the essential details for your setup of your radio control link. Now you can see here that there are many of them. The best idea is to choose official ones as a beginner. And I happen to know that I am using Express LRS, and so I'm just going to find ELRS if I can find it here. There it is. And I am flying my quad at 250 hertz. You would choose the one that would be appropriate for your quad, but I fly Express LRS at 250. I will choose that one. And then it gives me an opportunity here to choose a few options. And I'll choose the ones that are going to be most appropriate for my style of flying with this quadcopter. So I'm going to be flying this as freestyle. I know that my Express LRS is connected separately on a separate UART. It's not through an SPI connection, so I'll choose that. I like, in my case, to have single cell voltage as the telemetry that's coming back. And I don't need cinematic rates because I'm not going to be flying this one cinematically. So I've chosen those ones. And I'll come down here and I'll simply say pick. And that has now been basically applied to the quadcopter. Well, not until we hit save and reboot. But we've done the RC link. So now what we will do is we'll get rid of the RC link there. We will come down and we're going to do a very basic tune. Okay. We'll get rid of Express LRS over here so we can see what we're looking for. And what I'm going to do is, I wish there was an easy way to do this. Status. I'm just going to go with official. And we can do a couple of things here. If you look, defaults, tune and filter, that will take you always right back to the basic Betaflight default tune. And that one will always be a safe place to start and to build your tune out from. And this one says tune and filters. This one over here says just whoops, I need to click it, Betaflight tune defaults. What I am going to do, because this is my very first time building a 7-inch quadcopter, which is a different beast than a 5-inch, I'm actually going to just stick with the default tune and filters. And what that basically lets me do is lets me choose this one up here at the same time. But what we can do is, I won't choose that. I'll just choose this one here that says defaults. And we'll see about the other one too. So I'll choose this defaults. There's nothing else extra I need to do in here, no other things to select. So I just choose pick. Having done the tune, we're going to come and take a look at the video transmitter. So in Betaflight, in order for an analog video transmitter to work, we need to import the VTX tables to it. It might be true for HD audio or HD video too. I don't own HD, so I don't know if it is. It may well be. But what we're going to do is we are not going to come here to official or whatever. Let me erase that, and you can see that here there are many, many, many different options available. Now, I know that in my quadcopter, I'm using a SpeedyB TX800 video transmitter. And so I'm going to choose that one. It just happens to be listed right here at the top. But you would go and choose the one that is appropriate for your particular video transmitter. What we can tell is I'm going to choose this one. We'll choose the regulatory domain, which is the one that I'm using, which is in the United States or Canada in this case. And I will pick this one. And I will agree to this and say it's fine. Now we have a VTX that's set up, and I'll show you in just a moment what that does. Actually, what we'll do is we'll save and reboot these right now. And I would like to just take a really fast moment to talk about the video transmitter setting that we just did, which if we come down here to video transmitter, you can see that by selecting that preset, we have all of the settings, all of the channels and the bands that are available to the video transmitter. But more importantly is down here, we have all the power settings that are specific to this video transmitter. And that's why we need to make sure we're choosing the right preset for the video transmitter. In analog video transmitters, these settings are always the same. The channels and the bands, they're all the same for every analog video transmitter. However, the power settings are not. Every different manufacturer has different power settings, and if you don't enter those correctly for your video transmitter, it's not going to work right for you. So when you are on that presets page, which is we are back to here now, make sure that you choose the video transmitter preset that is appropriate for your video transmitter. If you don't find it in here, don't worry. You can actually go to the website of the manufacturer of your video transmitter, and they will provide you, you'll be able to download the VTX table for that particular video transmitter. And then you can just simply come back here to the video transmitter, and you can see here where it says load from file. And you'll just be able to load it from that file from your computer, and it will be set up properly for you. One more thing we're going to do in here, and that is we're going to set up a filter. And again, I would say really stick with just your basic Betaflight filters here. And what I'm going to talk about here quickly is these different sort of levels of builds. You can see here that there's something that's called a normal build, or a clean build, a noisy build, very noisy, very clean. What does that mean? Basically, the cleanness of your build refers to how much vibration and noise it makes. So the fewer wires you have bouncing around, the cleaner and smoother the bearings are on your propellers, the tighter all of the screws are on your build. If you've used damping grease between all of the carbon, all of those things will have an effect on how clean or noisy your build is. So the more things that are flapping around and vibrating and loose and causing issues of electrical noise and vibration, you're going to be getting into this noisy and very noisy. A clean or normal build, normal is going to have some loose wires around. It's maybe a quad that's been used for a while. The motors aren't perfectly brand new, but they still work really well. And so it's still a good, nice quadcopter. Very clean. This would be a brand new, completely, perfectly built quadcopter by an expert builder. That's not me. For most people, sticking with normal will be a very good, safe place for your tune and for your filters to be. From there, you can always change them after to get better performance. But if you choose kind of the wrong way, too clean or too dirty, you'll get poor performance. So I'll leave it up to you to decide whether you think your build is in the clean, normal, or noisy zone. I would stay away from the very clean unless you're a really good builder with, a very cleanly built quad. The other thing to take a look at here is this idea of with RPM filtering or with no RPM filtering. If you use BL Heli 32 ESCs or BL Heli S ESCs with BlueJ firmware, then you should choose with RPM filtering. If you are using an ESC that is only BL Heli S firmware, then you need to choose without RPM filtering because it doesn't have BL Heli S basic firmware does not have RPM filtering capacity. So I am using a BL Heli S ESC that has BlueJ firmware on it. I consider myself to be an okay builder, and so I'm going to consider this one to be clean. I did use damping grease, and it's a brand new everything. And so I'm going to choose this as my filter settings. And just need to say pick. And now that I have done that, we can come back here, and we can see that in the categories, we have done the video transmitter, a tune, the RC link, and the filters. These other ones, the LEDs and modes and OSD and rates, those are very, very personal to each quad and to how each person likes to have things in their video display and that. And using a preset is probably not a good idea in those. You get to set them up more how you want them. And that's especially true with something like rates. So having done those 4 basic options in here in the presets, and we've saved and rebooted this, we can then move down to the next tab, which is PID tuning. PID tuning is a monumental thing that we're not going to get into right now. What we're going to get into is only this rate profile settings. And what you should do in here is go in and set the rates that you normally fly with your quadcopters. Now, I choose to fly with actual rates. They make more sense to me. And I like to have a center sensitivity of 200. My maximum rates are 900 and 800 for yaw. And I put in a little bit of expo in all of those, and I end up with a curve like this. It's a fairly sedate curve. It's not a really aggressive one. Most people will be comfortable, if you're new to this, most people will be very comfortable starting out somewhere between 700 and 900 for their rates, and then you'll figure it out from there. And that takes time. But getting this set up as a basic sort of feel for where you're going to start is a good idea. The PID profile, we're not going to work on that until we actually get the quadcopter built and try flying it a little bit to change the settings. And that will be the same thing here for the filtering. Once we've taken the quad out and flown it a little bit and understand how it's acting, we can come back and change the filter and PID profile to suit our situation better. So we'll just make sure we've saved this. The next part here, we can see we have the receiver and the modes. And to work with those, we're going to need to be using our radio. And so what I'd like to do is just bypass those, and we'll finish that off at the end once we've set up the other main features for the actual quad itself. If you are using a GPS, you would come in here to the GPS tab and just make sure that you have the U-blocks protocol selected. Leave it on auto config, that's just fine. And there's no reason not to use Galileo, so make sure you click Galileo on. And then you would come down and save and reboot. What we're going to do now is we're going to go to the motors tab here, and we're going to set up the motors to work the way we want them. Now to do this, of course, we're going to need to have a LiPo so we can actually activate the motors. Click on the motors tab here. What we're going to do first is come here and set up the ESC features that we want, and then we'll go through the process of making sure that the motors are spinning the directions we want them to spin, and that the correct motor is spinning in the correct order, or that each motor spins when it's supposed to. For this quad, I'm using an F405 processor. I'm going to choose D-Shot 300 as my ESC protocol, and that will be just fine. I'm not using an ESC sensor. That's usually with BLHeli32. Because I am using BlueJ soft firmware on the ESCs, it does support bidirectional D-Shot, which is a very useful thing with filtering. And so I'm making sure that that is activated. And then here we need to know the number of poles in the motor. And that basically means the number of magnets in the bell of the motor. Now, most motors over the sort of the 22 XX size and going upwards, or even the 20 millimeter motors and going bigger, they basically all have 14 poles. And so that's what I'm going to put in. My quad is using 2807 motors, and they do have 14 poles. So there's what we're going to do there. This is not a 3D ESC motor. I'm not flying up and down in 3D mode, so that's nothing that I need to do. So these are all set. You'd come down here, mine seemed to be fine for me, and then you would hit save and reboot. Having done that, we're going to come back here now, and we're going to make sure that the motors are working the way we need them to work. What I'm going to do is connect a LiPo here to my quad, and we will just take a quick moment here to test how these motors work. Make sure that they're spinning the right way, and that each motor that should spin is spinning. So on a quad, we would label these as, in the back right as number 1, motor 1, front right is motor 2, back left is motor 3, front left is motor 4. And so when we test them, we want to make sure that when I'm trying to test motor number 1 spins. Is we're going to come over here with the LiPo attached, and we're going to say, I understand the risks. And we're going to activate the motors. When you do that, make sure you do not have props on your quad. Right? Working on your desk with LiPos plugged into your quad, having props on is just foolish. So take your props off before you do anything else here if you have them on. We're going to say here, I understand the risks. And that basically now activates all of the motors. And what we're going to do is we're going to go to each motor and activate it, and we'll do two things. We're going to make sure that when I come here and I choose to activate motor number 1, that really motor number 1 is the one that spins. And if it isn't the one that spins, we're going to have to fix that later. Okay. The second thing we're going to check for is also the way it is spinning, the direction. I fly my quads with the propellers spinning outwards. Okay, so this would be spinning out, this is in. So I fly with mine spinning outwards. I find that that helps keep my camera clean and just a few other things in terms of flight. And so I have set up here, my motor direction is reversed because that is how I like my propellers to spin. If you normally have your propellers spinning inwards, you would make sure that this is turned off. I'm going to turn that back on because that's what I want. And then I'm going to come here and make sure that you don't have your props on when you activate this. And I'm going to click here and just very gently raise it. And at the same time, I'm just going to be very gently pinching on the motor itself. Just raise it very slow. And I can see and I can feel which way it is spinning. And I can feel that it is, in this case, it is spinning this way, which is the props out. And this was motor number 1, and motor number 1 activated. I'll do the same thing now for each of the 4 motors in turn to make sure that they're all doing what they should be. And if any of them are wrong, I'm going to write that down so that I can fix it afterwards. So I'm just going to do that very quickly. Just come here. Yeah, that's good. That one is good. Whoops. And that one is good. In my case, it's kind of luck, everything worked out just fine, how they were supposed to. That typically doesn't happen. If we have problems where maybe I clicked on motor number 1, but motor number 3 started spinning, or maybe motor number 1 was the correct one, but it was going in the wrong direction, we need to fix that. And the way we can do that is with these two buttons here. The first button, which is reorder motors, lets us make sure that the correct motors spin if they aren't spinning correctly. It's a very simple process. I'll take you through it, but I'm not going to do it because mine are correct. But you just click reorder the motors. You just make sure your props are off. You have to say that you're doing it, and then you're going to hit start. And what it's going to do is it's going to start spinning one motor. And what you need to do is click here to say which motor that is. So this is this one. I'll click on it. Now it's spinning another one. In this case, it happens to be there. So I'll say it's this one spinning. Now this one is, so I would say that. And finally, in this case, that one is spinning. So I'll say there it is. And then save. And it will go through the reboot process. And what we need to do now again is go back to that motors tab. That will have fixed the incorrect motor spinning. But if the motor direction was wrong, we would also need to come here and choose motor direction. And we would just click on that. Again, we get this warning. And you can either do it as a wizard or individually. I like to do it individually. You click here, and what happens is if you push on a motor, like number 1, it will activate that motor for you. And you'll be able to see which way it is spinning. And if it is wrong, you can choose either to reverse it or put it back to normal, whichever the case may be, in order to get it to spin the correct direction for your quad. It's a very simple process. When you want to do number 2, you just go over and you choose number 2, click and hold, and it will activate that motor, and you'll be able to see which way it is and make the change necessary. Now, all of mine were fine, so I'm not going to change anything here. I'll just close this. For the motors tab, that is all we need to do. As long as we've made sure that all of the motors are spinning correctly and in the correct direction, we're golden, and we'll be able to move on to the next part. We're getting really close to the end here. We're going to skip the OSD just for a moment, and we're going to come down to the video transmitter, because that is kind of the last place we actually need to do anything to set up the quad. So I'm going to come here to the video transmitter, and we've talked before about how we can use a preset to get in the VTX table that we need on here. And if you had any trouble with that, we also talked about how you can go to the manufacturer's website and download their table from their website and then upload it into Betaflight as well. So once you've done all of that, what you will need to do is you'll just need to come in here and set your settings that you like to use for the first time. So I typically fly raceband. I typically fly on channel 4. For right now, because I'm working with this on the desk, I'm going to give it a very, very, very low power or none. So I'm just going to put this on 25 milliwatts like that. So it's a really low power, so it's not going to overheat on the desk. That is all that I should need to do on here. And I will come down to the bottom and click save. The other thing we can do here is we can look at the values that are already set up, and we can see if our either smart audio, if we're using that, or if IRC Tramp, which is what I'm using in this case, we can see if it's connected properly and active. And you can see here that in my case it says true, and that's good. If you have something here and it says false, it could be two things. Either you've chosen the wrong port in the ports tab, or it might be that your VTX is actually not powered on, and because it's getting from a different voltage source than is activated through the USB. So just depending on what your case may be, plug in a LiPo and see if that changes it. So we are here now at the basic end of the quadcopter setup itself, except for one thing, which is this. We have two things more, actually. We have this on-screen display, and then we have the receiver and the modes to set up. Now I'm going to come here to the on-screen display, and so what we're going to talk about in here are just some of the features that are, or some of the pieces of information that are probably really important to have on there, and then you can choose others from beyond that. What we want to be able to know is information that's going to help us understand the safety of our quad and how long we're going to be able to keep flying. And so what I typically do for myself is I will make sure that I have a battery voltage, and I like the average cell voltage. And I will look also at how many milliamp hours I have used from my battery. And those will give me an idea of the current state of my battery, how much power is left in it, and give me an idea of how much longer I can fly. Down here, if you want, you can include your craft name on the on-screen display. I do that. It's right over here for me. If we continue down, on this particular quadcopter, I have a GPS. And so I am going to put on some things that the GPS will give me that will be helpful. So I'm going to have on here the number of satellites that the GPS has. I can get a speed from my GPS, which I've got down here in the lower corner. And I can get this home direction arrow, which will give me an idea of which way to fly back if somehow I get disoriented. And that was something that you would only get if you had a GPS installed on your system. So if you don't, you wouldn't need these. The other thing I want to know is how good is my radio connection to the quad. And because I'm using Express LRS, the best way to get that information is by using link quality and down here, RSSI DBM. And we can see those are both right here on my on-screen display, right front and center where I can see them with no problems. So I'll be able to understand how good is my radio control link at any given point. And for me, that is all that I like to have on my screen. Some people like to have more. They like to have, artificial horizon and crosshairs and stuff. I don't. I like my screen to be as simple and clean as possible when I'm flying. There is one thing here that we see right in the middle, and that is a warning zone. And what we see there, in this case, low voltage, those words are not displayed at all unless there is a need to display a warning. And that's what will happen in there. And so if we come over here, we can see that on the right side of the OSD, there are some warnings that can be displayed. And again, you may not want any of these, or you might want all of them. What I typically will do is I will have it, if there's arming disabled, that will pop it up, and that just tells me that there's something wrong that prevents me from arming it. I want to get a message if my battery is getting to a very low state. So I've got critical, not full, a battery warning. I like to have it when I get an arrow or shows me which way I should flip when I'm using a crash flip. If it's fail-safes, I'd like to get a message saying fail-safe, and so it shows me that. Because I am using a GPS, I'd like to have this idea of a message when it tells me I can't use my GPS rescue. And so that's what those two will tell me. And that was an extra safety feature so that I know, oh, don't fly right now, I can't do it. And then I also want to have my link quality and my RSSI DBM, which I use for understanding my Express LRS link. I want them to be displayed as warnings too if they start to get really terrible, so that I know that I should change my flight and come back. And so those are the things that I like on my on-screen display. You can choose the items that you like in particular and have them show up on your screen. The only other thing that you might want to take a look at are the units that you're using and this idea of which video format. So NTSC and PAL are the basic analog video formats, and they have very, very different screen dimensions. And so you need to make sure that you choose the right one. I always fly with PAL simply because it gives me a little bit more vertical real estate. But If you choose to fly NTSC, just understand that you would get a much smaller screen space and you would have to readjust where your items are on the screen. Now, of course, if you're using HD video, make sure you select HD. I'm just going to put mine back to PAL because that is what I use. The final thing we'll talk about here on the OSD page is the post-flight statistics. And these are statistics or pieces of information that will be displayed on your goggles after you have landed and disarmed. And there can be a lot of information you might want here or very little. I like to know the maximum current that I ever drew on the whole flight, how much of the battery Betaflight thinks I used, what is the active voltage right now. When you land, there's going to be a specific voltage, and that's this next one down here. And that's just when you hit the ground and disarmed, this was the voltage. But after you disarm and the quad's not being used, the battery voltage is going to rise slowly. And this here, which will show you the battery voltage in real time, will show you how much it comes back up after your flight. I also have here my minimum voltage during the flight. And there are lots of other ones in here that you can choose to have on. You could put on minimum RSSI, your flight distance, whatever you might choose. For me, those are the ones that I like to see at the end of my flight because they give me information I can use later. So having done that, we're going to click Save. Now we have done the basic setup for the whole quad to make sure that it can fly and it has all of the settings that it needs in order to do what we want it to do. However, what we haven't done is connected our radio transmitter to the quad, and we haven't gone in here and set up the modes, which is all of the switches that allow us to turn on things like the beeper or change flight mode or activate a return to home rescue. Those kind of things we have not set up yet. Now that's a fairly involved process, and so we're going to take a look at that in another video where we'll take a look at exactly how you can set up your model in your radio and then make sure that it connects to the quadcopter and that you have all of the switches and settings the way you need them to be. So I hope this initial go through of the settings has been helpful for you. Thank you very much for watching it. Come back to the next video so you can learn how to connect your receiver and set up all of the settings for the switches, and you'll be good to go. So for now, thank you very much for watching. Until next time, have a great day and safe flying. Take care.